Hello and welcome to the Ramalama channel. Today I'll be covering question 27 from the June 2015 Geometry Common Core regions. Alright, let's get this started. So the coordinates of the endpoints of line segment AB are A, -6, -5, and B, 4, 0. Point P is on line segment AB. Determine and state the coordinates of point P such that AP to PB is 2 to 3. The use of the set of axes below is optional. Alright, so I'm a very visual person, so I already drew out the coordinates and the line segment. Now we're trying to figure out where to place point P on this line segment so that point P makes up a 2 to 3 ratio between AP and PB. Alright, so let me just draw like a nice very general sketch of this AB line segment here in a horizontal form, right? So when we place our point P on this line segment, point P is going to be closer to A than it is to B, all right? We're going to, again, divide this line segment so that we have a 2-part to a 3-part ratio on this line segment. Now, let's emphasize that these are parts, right? Let's reflect back to middle school. So since these are parts, that means to obtain our whole, we're going to take the sum of these two parts. So if the ratio from AP to PB is going to be 2 parts and 3 parts, how many parts do we have in total, right? That's going to be our next question, and it turns out to be 5 parts. So let's see, if we have a total of 5 parts and we want to divide up the first section to be 2 parts to 3 parts, then we're gonna try and find 2/5 of the distance of the total distance so that P can actually be in that area closest to point A than to point B. You can also write out that this is a 3/5 part ratio, but you're not gonna need that. You only care about how close we can get point P to A, right? Now, reflecting back on this line segment, right, it's diagonal. So not only are we seeing a horizontal change, right, we're also witnessing a vertical change. Okay, so what we're going to do is we're going to find the horizontal change, find the vertical change, and then we're going to take 2/5 of those changes, and it'll help us get from point A to where point P should be on the diagram. So let's do that. So if we go back to here, right, A and B, I'm going to label this x1, y1, x2, and y2 here. Now, if I'm going to determine the horizontal change, I'm going to take the difference between x2 and x1. So that's going to be x2 minus x1. That's going to give me, let's see, that's going to be 4 minus -6. 4 minus -6 is going to be 4 plus 6. It's going to be 10. So that means there's a horizontal change of 10 units. You can actually count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, next one is going to be that vertical change. It's going to be y2 minus y1. y2 is 0 minus -5. It's going to be 0 plus 5. That's going to be 5. Okay, so we're not done yet. We just discovered the total horizontal change and the total vertical change, but we want to find 2/5 of both changes so we can indicate where point P is going to be. So let's do that. So we're going to do 10 times 2/5. That's going to be, we can simplify. We can do 5 goes into 10 twice. 2 times 2 is 4. We can do 5 times 2/5. 5 goes into 5 once. That's 1 times 2. That's 2. So here we have, from point P, these numbers tell us that from point A, from point A, we're going to do a horizontal change of 4 and a vertical change of 2. So this all becomes the following. Point A is -6, -5. If we want to find out what point P is going to look like, we're going to do -6 plus that horizontal change, 4, -5, plus that vertical change, 2. We're going to end up with P. -6 plus 4 is -2. -5 plus 2 is -3. And we found our location for point P. We can graph it if we need to. Let's see, -2, -3 is going to be right here. And that's where point P is. Any questions, leave them in the comment section below. like and subscribe. Thank you.